What if we build our solar farms not here on the ground, but way up in space? Okay, so let's get right into why you'd even do that. Here on Earth, solar power has some pretty big limitations. I mean, at night, there's no sun, so no power. Obvious. And clouds, rain, bad weather, it all gets in the way. But in space? Well, the sun never sets. There is no weather. It's just constant, unfiltered sunlight, 24/7. And the result of that? A solar panel in space can generate up to 40 times more power than the exact same panel would down here on Earth. I mean, 40 times. You know, the basic concept isn't even that new. We actually already do this, just on a much smaller scale. Think about satellites or the International Space Station. Once we launch them, they unfold their solar panels to power everything they do. The grand idea here is to just take that same exact principle and scale it way, way up to power our cities back on Earth. And yeah, that is the big question, isn't it? It's always the first thing people ask. You can't just run a giant extension cord from orbit, right? So how in the world do you get all that incredible, clean energy from a satellite all the way down to the ground? Well, believe it or not, someone actually figured that out a long, long time ago. You might think this whole thing is some brand new futuristic idea fresh out of a lab, but the dream of space-based solar power, it actually goes back more than half a century. It was born from the mind of one really forward-thinking scientist. So, way back in 1968, a scientist named Peter Glaser first patented this idea. He proposed that we could collect solar energy in space and then wirelessly beam it down to Earth using microwaves. Now, at first, people thought it was a little out there, but then in 1973, the oil crisis hit, and suddenly the entire world was desperate for new energy sources. And that's when organizations like NASA started taking Glaser's wild idea very, very seriously. And when I say they took it seriously, I mean they thought big. The project they drew up was absolutely massive. We're talking about a solar array in orbit that would have stretched for 5 to 10 kilometers. I mean, that's the size of a small city just floating in space. An engineering project on a scale that was just almost unimaginable. So what stopped this incredible vision from ever happening? Well, it was this number right here. The estimated price tag, and remember, this was back in the 1970s, was $1 trillion. That's a T. It was, to put it lightly, just astronomically expensive. And it really all came down to logistics. To build something that big, they figured they'd need to launch about 10,000 tons of material into orbit. Back then, launching just 1 kilogram of anything cost about $20,000. The launch cost alone made the whole thing completely impossible. So, the dream was shelved, and the idea kind of got relegated to the world of fiction. But the idea didn't just die. It just moved from the engineering blueprints into the pages of books, and it was kept alive there in the imagination of one of the greatest science fiction writers of all time. Yep, the legendary Isaac Asimov. He wrote about this kind of thing all the time. He saw solar energy from space as the ultimate clean power source for humanity. He even dreamed up a future where our most energy-hungry industries, our factories, our data centers, could be moved completely off-planet, powered directly and endlessly by the sun. And for decades, that's exactly where the idea stayed, as this really cool concept in a sci-fi novel. It was a fascinating what if, but it just wasn't something for the real world. That is, until very, very recently. Because that massive barrier that stood in the way for 50 years, that gap between the theory and actually doing it, well, it's finally been broken. The science fiction dream is all of a sudden becoming a scientific fact. This incredible breakthrough came from a team of researchers at Caltech. Their project is called MAPLE, which is short for Microwave Array for Power Transfer Low Orbit Experiment, and they set out to prove once and for all if this could actually be done. And they did it. Here's how it worked, in a nutshell. Their test satellite collected solar power, just like a normal panel would. Then on board, it converted that electricity into microwaves and precisely beamed that energy down to a special receiver on the Caltech campus. That receiver caught the microwaves and turned them right back into usable electricity. Now, just let that sink in for a second. For the very first time in human history, power was collected in space and delivered wirelessly to the surface of the Earth. It was only a tiny amount of energy, of course, but it proved the principle. Peter Glaser's idea from 1968 was no longer just a theory on paper. It was real. It was possible. So, now that the science is proven, what happens next? Well, this is already moving way beyond a simple lab experiment. Companies are taking this breakthrough and are already designing the next generation of infrastructure in space. For instance, take a company called Etherflux. They're actually planning to build an AI data center in space, basically making Isaac Asimov's vision a reality. And why would they do that? Because training and running AI requires a colossal amount of energy. By putting the data center in orbit, it can be powered directly and continuously by the sun. And here's the best part. Any extra power that it generates can be beamed right back down to us here on Earth. So the most important thing to realize here is that we've crossed a major threshold. The conversation has completely shifted from if this is possible to when it will happen. Think about it. The two biggest roadblocks from the 1970s, proving the technology works and the insane cost of launch, have been shattered. The tech is now demonstrated, and launch costs are plummeting thanks to things like reusable rockets. What was once a trillion-dollar fantasy is now becoming a tangible commercial reality. Which leaves us with this one last pretty amazing question. We already get our light from our nearest star, the sun. But will we soon be getting our electricity from it too, collected by these giant power stations floating silently in the vacuum of space? It seems the dream is alive once again.